Great, good evening. Warm welcome to you all for this first event of our fall term lecture series on making architecture. To introduce this topic, let me refer to my annual message in the Black Book, which from my informal polling, I believe most students have not read. How many of you read my message in the Black Book this year? Faculty, please keep your hands down. Okay, here's my point. I think to get your attention, I will send it to you next time by WhatsApp. You guys don't even read emails anymore. So in the Black Book message, I mentioned there may be no other discipline or profession than architecture that demands both left and right brain capabilities in equal measure. And after Leonardo da Vinci, who else can claim to be equally brilliant in both? And so this, I think, explains why architecture is so challenging and demanding to learn, to teach, to practice, and most likely never to master. So as students, teachers, and practitioners of architecture, we must strive to be ambidextrous. I use this word not literally in the sense of being able to use both left and right hand equally well, but to engage both of our left and right brain attributes. So you know the left brain is the center for verbal, logical, analytical, neural, rational thinking. And the right brain is more visual, intuitive, creative, spatial, perceptive, feeling. Specifically in architecture, to be committed and competent in both the creative, innovative needs and the pragmatic, technical demands of architecture and building. It has been said that design is where art and science break even. Architecture succeeds where our left and right brains intersect, where research informs design, where critical thinking leads to creative insight, where craft and making translate design ideas into built realities. Then, as Winston Churchill famously observed, we shape our buildings, and then they shape us. So this fall term, we have invited 4 leading architectural practices to present their current or recent projects with in-depth case studies of the design process, from initial concept to final built realization. I think this is very relevant and I think helpful to all of the students with their studio projects. In reverse chronological order, they are November 1, Professor Brian Anderson of Purcell, conservation architect for conversion of Central Police Station, now known as CUHK. October 22, Jamie von Klemperer, president of Cohn Pedersen Fox. Their exhibition, KPF Making, was on display in our ground floor atrium last month. October 11, which is this Thursday coming up, Professor Eric Howler of Harvard and his practice, Howler and Yoon in Boston. Eric has been an external examiner for the past 2 years. And this evening, for the first lecture of this series, I have great pleasure to welcome Earle Briggs and Giles of Reverie Architecture, a practice originally founded as being top architects in Canada. And they will present the Shichu Center for Chinese Opera, now nearing completion at the West Kowloon Cultural District. And I think also the Hong Kong campus of University of Chicago Booth Business School. Earle Briggs is Managing Director of Reverie Architecture in Hong Kong, familiar to many of you as our external examiner and guest critic at our school the past 2 years. He was educated at Carleton and the AA London. He has worked with Frank Gehry on the Disney Concert Hall and other projects, and as well with Bing Tom both in Vancouver and now here in Hong Kong. Giles Hall is an architect with Rotary Architecture who has made key design contributions to several of the film's projects, including the Grand Theater of the CUHK Center. Giles was educated at University of Waterloo and the Earle program, and like Earle has particular design expertise in performing arts techniques. Finally, let me conclude my introduction this evening to say a few words about Bing Tom, who tragically passed away 2 years ago, almost to the day, October 4th, 2016, at the age of 75, while here in Hong Kong on a visit for the CUHK Center. I know this so precisely because he was scheduled to give a master's seminar to our M2 students, thesis students, during that same week. Although Bing Tom spent most of his life and career in Canada, I think he moved to Hong Kong when he was 10. So really considered a Canadian architect. He won the RAIC Gold Medal, and his firm won the RAIC Firm of the Year Award. Bing was born in Hong Kong, proud that his latest projects, the CUHK Center and Booth School, could be his legacy for us in Hong Kong. After his death, the firm name was eventually changed to Reverie Architecture, which is interesting. So any of you guys have a meeting in Reverie? Faculty, keep your hands up. Well, it means a state of daydreaming, of fanciful musing, or perhaps a fantastic or visionary idea. I think it's inspired by the notion of dreaming bigger in our architectural work. Since at the end of the day, as professional architects, I believe, our job is not simply to provide what the client says he wants, but to offer what the client never dreamed was possible. So on that note, fitting the lead design associates of Bing Tom are here with us this evening to share their detailed design development of these significant projects from design concept to build completion. Please welcome Earle Briggs and Giles of Rotary Architecture.
Thank you, Professor Nixon. Thank you for the invitation to discuss our latest project at CUHK Center. We have a clip at the very end of the University of Chicago School of Business, but it's not part of this discussion. We just thought we'd give you a clip, and it does open December to the public, so I invite all of you to attend on December 2nd. So the title of this talk is about elevating a historic art form, and it has several meanings to us, but the most important one is the desire to promote, modernize new technology, and elevate an ancient art form, allowing it to continue for another 1,000 years. Other meanings I think will reveal themselves in this talk. As the first project of the West Kowloon Arts District, the CUHK Center is envisioned as a cultural sanctuary of the city, blending theater, art, and public space. Our approach was to create as a contemporary expression of the art form that would both celebrate and promote its development and evolution. Our project is strategically located at the gateway to the entrance of West Kowloon and adjacent to the MTR and next to the XRL, recently opened, which is bringing a catchment of 30 million people to the West Kowloon district. In this talk, we will talk about the 2.7 billion, 32,000 square meter complex of CUHK Center, housing an 1,100 seat opera house, 200 seat theater, a 100 seat seminar rehearsal spaces and practice room. And it has 2 levels of retail, lack of those facilities, really frustrates. Okay. As an office, rather than a preoccupation, a distinct office style, we focus on the importance of each project as a specific response to the art form, site, urban condition, and culture. Beyond artistic forces and urban influences, the role of architect must also address the dynamics, cost, schedule, and quantities. While this is a technical aspect of architecture, in a way it defines the percentage of design that is part of making buildings. And I think Frank Gehry once said to me that design is only 20% of making buildings. So I'm happy to have a discussion about that after the discussion. I'm not sure, just to provoke discussion, let's say. But this project, the CUHK Center, was especially interesting to us as there were no precedents for a purpose-built CUHK opera house, as the art form had been performed previously in bamboo theaters or found spaces or open pavilions, historic buildings. Giles will talk later about the nature of the art form and the discovery from discussions with performers and stakeholders about the art form. For an architect, it is in a way an extraordinary opportunity to be the first to design a purpose-built CUHK opera, acoustic and room. Opera, both East and West, represents the most complex of art forms and building types, combining acoustics, theater design, and complex reading systems, complex mechanical design needed to create quiet spaces, and complex structural solutions to achieve intimacy, sightlines, and isolation from exterior noise while complying with local regulations, which for Hong Kong is complicated by the fact that there isn't a theater-related code to work with. In fact, we were told that this is the first theater to fall under the BD jurisdiction in 20 years, because we're public-private clients. To address this complexity and recognizing the collaborative nature of our process, we assembled a team of experts in the field of acoustics, theater design, lighting, structure, landscape, signage, specialist cost consultants, facade consultants, and MEP from 3 continents and 5 different time zones. As we will discuss through this lecture, it is the architect's job to be the team, and the only way to do this is to understand all of these disciplines. And as an architect, we must relentlessly question our collaborators, clients, users, as we are ultimately the conductor of sorts. We have to make informed decisions and compromises, orchestrating the final design to informed, selective input from our parties. This is critical to the success of the project, and I think of design. To ensure the design intent is understood and implemented requires intense coordination by all parties and continues throughout the construction process. Professor Nelson and I spoke about this at the recent site tour a few weeks ago, and how important this is. And I recall during the design, we spent one day a week with our mechanical consultant in their office for 6 months, reviewing their BIM model. And when I discussed this with friends, they had never heard a working method like this, but it is really essential to this very complex building site. And I think the reason is if the process isn't coordinated, as you move through the process and further develop design, an uncoordinated system could seriously unravel the whole project. So it is the level of coordination is taken very seriously. With the complex relationships and technical constraints required to achieve this complex building type, it is critical that all parties understand the reason behind the decisions. At the beginning of the construction process, this starts all over again. And we spent over 3 years explaining to the contractor and the sub-trades the potential implications of their per-work push-out on acoustics, for example. So it was very important for them to understand the process that we went through for the first 3 years of our design. So it is a responsibility to educate the contractor. And I think often architects are absent from the construction process. And on this project, we moved our office, entire team, and the joint venture Earle onto the site. There were over 15 of us, and we have been there for 3 years. And I think this has contributed, to the success of the project. I think moving towards the beginning of the process, to work with our consultants who were in different time zones and different continents, to achieve that level of coordination, we needed a method to work in real time to develop the design. And it was important. The BIM model became a platform for this to happen. It also allowed us to work, our office, main office in Vancouver and office in Hong Kong work together. And we were able to work 24 hours a day, 12 hours in Hong Kong, 12 hours in Vancouver. And this, again, allowed us to move the project forward in a very tight schedule. It also created some very complicated issues in terms of technology. And again, it's a technical issue, but we had to do a lot of research in terms of how to develop a way of working across Trans-Pacific. And after the research with Autodesk and some very some experts in the field, it was found that we were in fact, the only ones who were working Trans-Pacific. There were a lot of firms working within the US with different offices, but we were really there was no one that we could rely on as a precedent. So we actually ended up spending a few million in Hong Kong just developing and purchasing equipment to speed up the save time in using Revit, because the model resided in Vancouver, so every change we made here had to go back to Vancouver and back to Hong Kong within minutes. And it was not a smooth ride, but we didn't give up on the BIM process because we would have lost a level of coordination that was essential to the project. So although it was somewhat inefficient, the efficiency of the BIM model overrode the loss in save time we experienced. So a brief discussion about the design of the building. Before beginning the design, we researched the nature of the art form, and there were 4 principles that emerged that guided the overall design approach. One was the notion of gateway, that as you can see in the image here, this is a place where, on the left, or the screen, sorry, where CUHK took place, and actually people arrived below the building, through the building, and turned around and there was a performance on stage. So in a sense, CUHK was both performance space and a gateway to a city. The other notion was the marketplace, where CUHK often, as we mentioned earlier, occurred in town squares, in ad hoc buildings like bamboo theaters, and so we felt that we needed to maintain that essence in the design of the CUHK Center. And also the notion of flow, which is very much a part of CUHK, part of the costumes and the beautiful movement that comes from the folding of the garments and just the fluid movements. Also, we were inspired by the urban form, the verticality of Hong Kong, the premium that land has and the shortage of public space. And so these were influences that we then took, became overriding concepts for the development of the project. As we studied this art form, the overriding concept that emerged was the need for a public space where people could gather. Traditionally, Sishu took place in the outdoor, in public squares, within nature, and often in temporary structures. With a relatively small footprint and the nature of opera and theater, which is mostly dark during the day and introspected by nature, it was clear for us that the theater should be elevated above the ground and located at the top of the building, where it could enjoy outdoor gardens, views of the city, and more efficient footprint, providing an open space below. As a firm, we've always looked beyond programming to give something back to the city. And with Sishu, a public space addressed the shortage of civic and public space. We also believe that the plaza was essential to promoting the Sishu art form by making it more accessible to the public, with free concerts happening within the plaza. The plaza also gave prominence to the retail F&B functions that would provide revenue to support the promotion of Sishu programming. Our design approach is always to begin with people and shape the space around their movement and desires. As you can see in this study, the movement of people from the MTR exiting within the plaza, circulation to the pedestrian mall from Canton Road, and the interior space and access to interior space. The plaza evolved as a theatrical space, allowing the public to witness the Sishu art form from several levels. This space, as I mentioned earlier, was not part of the program, but we believed that it will be one of the most engaging spaces and a valuable addition to the public realm of the city. In fact, during construction, at considerable expense, West Kowloon added a motorized rigging system to the ceiling of the plaza to facilitate Sishu performances. In our design for the plaza, to be successful, it had to be open as possible to the site, column-free, and at high volume with nature in the form of trees integrated into the space. As this was an unconditioned space, thermal comfort was a concern, and our engineers, Bureau Happold, did extensive modeling using bin models to ensure air movement and relative comfort. This, we believe, we have achieved from our experience of the space during the hottest summer months this year. Another issue that we did not anticipate was that the building department were reluctant to accept a semi-enclosed space, as there was no precedent for how to control smoke vented from, to control smoke egress. They rejected our proposal to naturally ventilate the plaza and insisted that we enclose the space. This would have undermined the entire design, as it was essential that this plaza be open to the street and open to nature. Only after simulating, using fluid dynamic studies by our mechanical engineers and conducting wind tunnel tests of the interior of the plaza, did the BD department accept the plaza as a semi-open space. I think in this video you can see a test that we did recently to get OP. So there was a fire conducted in the plaza, and the smoke exhaust system proved to be successful. So the double curved panels of the balustrades. We did a lot of investigation into what materials we could use in the plaza, but because the plaza is an exterior space, ED considered it a facade. And so the same criteria that applied to our facade applied to the interior of the plaza. So all the materials had to withstand the same forces as our facades. It had to be very robust and non-combustible. So it limited the palette, but we decided on, after, our preference was to use plaster, but really that trade and skill doesn't exist. It's hard to find really now anywhere in the world, but so we used aluminum panels, and they're double curved, and our requirement was that they be full height, 5-meter high panels, and the joints between as minimal as possible, so they were actually 4-millimeter joints. And we had an excellent contractor, and this was a mock-up done in China, one of the best fabricators in China. And it was extraordinary how accurate and beautiful these panels are. And they really, really do make the space. And I think I was, the surprise is the most complicated geometry, double curved metal panels are the most successful of the plaza. With simple 2D geometry, the rough plaster walls are very poorly done. So it's really a lesson, I think, to all of us, with the state of construction as it's evolving, is how do we achieve better quality construction. And I think the work, the plaster walls, the exterior walls of the plaza are all Venetian plaster, the balustrades are all metal, and I would say the Venetian plaster walls are not great. Because even though they're just vertical walls and curving, they're very poorly done. So it's a man-made process, whereas this is 3D printed structure, and then hand sanded, but essentially it's a printed product. So you can see the panel being installed on site and the amount of infrastructure to support the panel. Another challenge that we were faced with is a structural one. It was decided early on that the most efficient way to construct was to build the complex steel structure with a theater and stage tower at grade and then lift in a series of lifts. There were 3 lifts. The first lift lifted the theater structure up halfway. We then had to reinforce the super columns. There's 6 super columns. So we had to, contractor had to build 3-meter high by a meter wide beams that span between columns to brace them. And then after those beams were made, we then were able to raise the theater to the top of the columns. And then after that, they removed those, they sock out those beams, which are almost the height of this room, and removed them. So, and then the theater itself was built, and then that was the 3rd lift, and it was brought up to meet the structure of the roof of the theater. So this is a video of the roof structure of the theater. And then this is the final lift where the theater structure is being raised to meet the structure of the roof. There were some issues with the 2 not quite meeting, but they were solved. Yeah, so I think what we learned, the reason for doing this was to allow the project to be built top down, bottom up, so that once the theater was raised, you could then work below it, and then gradually build up the rest of the project. So this really sped up the construction, reduced construction time, and allowed the work to be done in the theater at the same time as work below. So it was quite an interesting process. So the next The next, oh yeah, I think we'll just walk through the plans, right? So just to give you an overview of the project, and then we'll talk about the facade, which is something that we generally in our projects leave until we've really set the interior planning and the functions so that we are sure that the building functions well. So this is the ground floor and upper ground floor. So on the right you have the NTR access or egress, both egress and access from the. So here's the NTR coming up into the plaza. We have the access to the main theater, which is going up 2 floors. And there's a transfer going up to the main theater. And this is the big ramp taking you up to the upper plaza. And then we have retail on two levels surrounding the plaza. And then this is just a diagram showing ventilation. So there's what we found is there, even in the hottest days, there's a very nice breeze that moves through the whole plaza. And there's a 27 meter high chimney here that draws the air up through the roof. So it actually, natural ventilation works very well. And this is the main entrance to the plaza. So this is the first level where you have the tea house. So you go up the grand stair to the tea house, and then again another restaurant, F&B, and then an escalator that takes you up to the next floor. And on the second floor you have an education center with rehearsal halls, practice rooms, and back of the support. And this is the access to the main theater. You come up and transfer to the next escalator that takes you up to the 4th floor. And this is the top floor, the 4th floor where you arrive. And then there's a crossover to Sky Garden at both ends. This is the main theater, stage, back of house. Well, yeah, so there are 2 floors, 5th floor balcony. And the roof, which is a metal, perforated metal roof that encloses the stage tower and all the mechanical equipment. It's quite an incredible space. It's unfortunate it's not accessible to the public. It's really good structure. You can see it here. We thought it would make an amazing rooftop bar. That's great. So I think as I mentioned, after planning the interior spaces, we considered the facade, which is a common approach to our projects. The approach to the facade was influenced by the costumes, the folds of the costume, and the notion of theater drape. And so this was the image of the drape opening up to reveal entrances, sky gardens, and light boxes and images of activity within. We looked at different materials. We looked at copper, which was our first preference, and we looked at ways of how we could achieve the folds and curving aspect of the costumes and the sense of the curtain. So this is our 3D printer in the office. This is a model partially complete of the entire facade. And this was the copper scheme. This is half pipes, different scale, welded together and perforated in locations, following the curve of the curtain. And we tendered this option, and the cost consultant told us it was on budget, and it came in way of double the budget. So we had to quickly redesign, and I think we then looked at a more modular system. So we realized the budget wasn't going to allow something as complex as this system. And in a sense, it's more the sense of using prefabricated modules and systems was more a way we're used to working. So I think this copper, very custom facade was a departure. And so this is the next study that we did to achieve this effective curtain. And each of these pieces is cut from a aluminum tube. So there was, from one tube we got two pieces. We could then flip the pieces so they were near to each other. And then, so the entire facade was made out of one module. And the curves, so this is an image of the CNC machine cutting the tubes. So it's an extremely efficient system, no wastage. And then the back panel is a sandwiched aluminum panel, which each panel in the project is at different connection points for the fins, so that you created this curving pattern as it went up the facade. And it's, I think it's we're quite happy with the result. It's the material that we used this is a performance mock-up of the facade. The material we used is a raw aluminum. It's a marine grade aluminum, and it's has a very, we like materials that have a natural quality, the patina, and so we did a lot of research, and we found that there was only one other project that we're aware of in the world that used this material, and that's in the Maritime Center in Denmark. But to be sure that this was suitable to Hong Kong, we built a full-scale mock-up, and it's been 3 years since it was erected, and it's weathered well, so we're extremely happy. And I think what's really exciting about the material is how it picks up light, and these are just images to show you how the aluminum changes based on sunlight and reflection. So it's quite an extraordinary system. And at night it's lit at the top of the ring beam and glows like a lantern, which was one of the original concepts for the project. I think we're very conscious of, as architects, of sustainability and recognizing that construction projects contribute over 30 to 40% of the world's pollution. I think considering systems, CNC, printing, robotics that can save material and waste, I think is a really important emphasis in our work, and it should be as all architects. So I'm going to hand the talk over to Giles to talk about the theaters and the making of the theaters. And, thank you.
So the first of the two main performance venues in the CUHK Center is the Tea House, which opens up directly off of the public plaza. So from the courtyard outdoor theater that Earle had spoken about previously, there's a grand stair which takes guests to the first venue here. This venue is a 200-seat black box tea house venue, and it's really the first of its kind in that the traditional tea houses which we've studied and visited during the design process are a more typical configuration in Canton province and more generally, where the performance is on a stage under a sort of Tory gate, and the audiences in these venues actually a lot of the time go for a meal and will go in and out during the performance. So the configuration of performances in these venues is quite different to that of a black box theater. And so in our process of design, actually, we worked closely with the client to do a series of full-scale performance mock-ups. So this space actually has gone through an extensive public testing. There were 3 overall during the process, where they experimented with different sizes of stage and relationships to the audience, as well as different, say, set pieces for the servings of food and the duration and configuration of the performances on stage. Because really nothing like this has ever been made public before as a ticketed venue. Again, during our process, we do extensive BIM modeling, but also in-house physical models to test scale and to field ideas to the client. This is one such model we did in preparation for one of those full-scale mock-ups. And the second of 3 mock-ups, where you see the dim sum servings with tea, which are one of the core focuses of this format of performance, and the pairings of food with the program on stage. During the construction process, we ran into some unique challenges to the Hong Kong construction industry. For performance venues of this type, theaters require a very specific noise reduction coefficient. So acoustics are really one of the core driving forces behind a successful performance space. If you have, say, the hum of aircon system or vibration in the structure which rattles lights during performances, it really downgrades the quality of the venue on the world stage. To achieve the requirements, we use a standard method called box and box. For these, you use a massive shell, which is typically a concrete block or poured concrete walls, and double thick slabs, where you actually have neoprene connections, and you build a room inside of a room. So you pour a second slab on top of the first, on rubber pads. And then inside of the first massive wall, you construct a second massive wall with an air gap, so that all airborne vibrations and groundborne vibrations don't enter into the space. Particularly what we ran into in Hong Kong is with the tolerances in the concrete pouring for slabs, as well as with the general workmanship on block walls. We spent many more hours on site than we had intended, monitoring the work and ensuring that we found remedial solutions. The important takeaway is to consider that even though you've got a robust spec and your drawings are in line, there's always site conditions and limitations that the contractors have locally, where you really need to be present and attentive. And don't take anything for granted. Because especially with this type of construction, there's really a cutoff point to where you're effective. After the room is finished, when they find a fault with the acoustics, it's too late. The chasing the kind of breach in acoustic in a room like this would be nearly impossible. So it's really something that you have to be present on site to achieve. Backing up slightly, again, centering off of the outdoor public performance venue. The main theater of 1,100 seats, as Earle had mentioned, is raised up for a variety of reasons. and exists on a sort of raised podium level with outdoor gardens and lobbies, but is also with an extensive back-of-house support structure. From the competition phase, where this partie was established, the freight lift elevators and the back-of-house support to that fly tower were really driving factors in the design. Also, reiterating that the formal expression of the building is also a response to the art form and its technical requirements. So the undulation in the roof is directly responsive to the fly tower, which is required for set pieces to be able to be changed at a rate that is meeting international theater standards. So we have in the CUHK Center, it's a 15 meter by 9 meter proscenium theater with a variable thrust stage and orchestra, as well as stage traps, side stages, and a rear stage for set piece exchange. We have a 24 meter fly tower above the main stage, which allows for those 9 meter full height pieces to be pulled up out of line of sight from audience members. And there's actually two sets of 40 high-speed winches at the high level, which allow for 3 meter per second set piece exchange, which is link speed basically. It's on par with the international standards for theaters of this size. The initial concept for the performances in this space really centered on the expression of the art form as it exists, but also with a view that having built now the first of its kind dedicated CUHK performance venue, that the art form had a chance to actually develop and grow in unique ways. So the courtyard typology, which has been referenced several times in different forms in the project, reappears here, but with some unique challenges. The traditional, as developed art form of CUHK is really an amalgam of the 4 main performance types, as opposed to the Western operas, which are a distinct departure from, say, ballet or say, dance or theatrical acting, or in some sense, the iconography of representation. In CUHK, those all have remained very tightly knit. So as well as being an acrobatic art form and an expression of martial prowess, there's also an extensive set of coded iconography in the set pieces of CUHK. And the facial expressions of the acrobats and actors are key to the success of the CUHK performance. Which is also to say that the relationship between the performer and the audience, which is always the heart of a theatrical event or a theatrical space, in CUHK has a set of its own unique and unexplored opportunities. Some of you might remember from a talk that Earle gave a few years ago, but this graph basically, as you expand out the scale of the theater, as more audience members are added, the potential for the engagement from the performer to the audience becomes more and more challenging to maintain, because in the performance realm in any theater, you really have a joining of 2 worlds: the back of house, the technical aspects of theater, and the world of the performer, and the world of the audience, where the relationship between those two, the energy contained between those two, is really the measure of a good theater. So So our main challenge here was with the sightline constraints. All theaters are driven by a specific ratio of visibility and acoustics. So with the frontal requirements of CUHK and the requirement to see those icons and the facial expressions, the client was really pushing for a single level theater with no balcony. It actually took over 6 months to a year for us to really convince them that the appropriate response was actually to maximize people as close as possible to the performers, not necessarily maintaining the kind of cinematic sightline that you get in the smaller scale bandwidth theaters, or as a precedent, say, cinemas, movie theaters, where the amplification of sound and the intensity of light in a cinema overcomes that expanse between you and the screen in some larger cases, or in some stadium performances where, say, you have a rock band on stage, that the experience of seeing the rock band can be overcome with amplification. In these sorts of venues, actually, the real key is to bring faces and audience closer to the performers and allow that relationship to be maintained. So the first hurdle that we had to overcome was the client. The second hurdle we had to overcome was the government. So Hong Kong has a fairly unique setup where for the last 20 years, most of the performance venues have been commissioned and overseen by LGSC or RGST, whereas the CUHK Center, being a semi-private organization, is actually under the purview of BD directly. So the BD officers, building department officers that we were interacting with, really had never had the experience of approving a theater before. And the Hong Kong Code is written excluding any specific reference to theater. So all references in the Hong Kong Code relate to cinemas or, say, rock venues or auditoria of that kind. So the assumptions inherent in the code did a few things. They would have increased the row to row, driving audience members order of magnitude further from the stage. They also mandated minimum height railings with no regard for the nature of a theater audience. The energy levels, the tendency to move about or to, say, rush the stage or to panic or to act recklessly, say, in a theater compared to a cinema or a sports venue are completely unrelated. So we spent over a year and a half, actually, it got down to the wire to actually get formal approval from BD. But the whole time it required us to drive the process, to maintain our conviction that the correct solution was the one we were proposing. And to achieve that, we had to reference international standards and also to commission through our consultants a series of extensive studies of sightline. And we really argued with the BD officers based off of the requirements of the art. So, referring back to that diagram, the relationship between the technical aspects of lighting, projection, and control of the performance, and that world of the performer, as related to the specific sightlines of every audience member, had to be studied, and in this case, actually almost quantified and proven to BD to achieve what we achieved here. And so during that process, this is an example of a series of progressive studies through the hall, which were actually tabled to BD during our discussions, showing them specific points of view in the theater. And this was this is the final outcome, but there was also cases where we would show the detriment to sightlines as you would raise that rail any higher than we have here. The other point of inspiration for the theater, stepping back a bit from the more judicious or technical side. As we develop the theater and we're looking to the art form for inspiration, that facial, the importance of the facial expression and the mask and the icon started to drive our design concepts. And we developed a series of flowing ribbons as a partie for the theater space. And those flowing ribbons began to carve up the geometry of the theater, creating opportunities to drive portions of the audience further forward in groupings, and to divide up the volume of the theater into meaningful acoustic spaces and also psychoacoustic or say familiar scales of space, which make the hall of 1,100 seats actually feel more like a hall of 600 seats. And that intimacy is sort of designed into the theater. During our process, we, as usual, do a series of physical models and mock-ups, as well as relying on our DIM to spearhead coordination. We have an extensive model shop, and we're working closely with our acoustic consultants, as we'll cover in a minute, to develop these. They're not solely scale mock-ups. They also communicate and explore the scale relative to individual audience members, and then also the scale relevant to the acoustician for them to do their acoustic studies and to drive the design constraints in a meaningful way. As the final image of the plans of the theater, that sort of flowing ribbon and the idea of mask start to communicate. Again, our process is also digital. We do a series of, say, renderings and digital mock-up studies to explore the space, and also commission professional model makers to help in the milestones of the design. As mentioned, Earle had mentioned previously, our team isn't just in-house. We have a series of external consultants that we work closely with and really learn from and say riff with or say a bit of push and pull during the process. So this is an initial concept diagram by our acoustician and theater consultant, communicating the key aspects of our design from their point of view, both in terms of sound scattering, absorption, and redirection of sound for reverberance. And also, as we developed our spatial concepts further, they would take that and iterate their models, doing extensive acoustic representations of that. And early on in the process, we had commissioned an orchestra actually at the APA to record a sushi performance with the scale orchestra that would be in our project finally. And that information throughout the design was fed back into these acoustic models so that we, our consultants and the client, throughout the process could sit in a specific seat in the theater, actually any of the specific seats, but we would walk them through a series of positions in the theater, and they could actually hear the real reverberance and the actual acoustic of that seat. So you could test for problem spots and hot spots, but also get a general feel for the room as a whole. And then also back to those physical models, which we would share with our consultants, and they would then use to feed their studies and to give feedback and specific requirements for the treatment of those zones. And then finally, in our process, in our specs for theater spaces, we have very strict benchmark requirements to achieve early troubleshooting for the acoustic assemblies in our spaces. So that actually helped us both in this space and the other performance venues in the hall, in the project. Because we were able to do these full-scale benchmark mock-ups off-site years before it became an issue on site. So that during the construction process, they were able to move much quicker. Even though the effort early on is maximized, as they came to site, we really had nothing except for some quality and QC assurance to do when it came to these assemblies. And again, that extends to all the acoustic relevant assemblies in the hall. As seen, the theater was actually built at grade and then lifted up. So one of the benefits of that was with the curving geometry in the hall, a lot of those complex connections were actually done at low level, not requiring excessive scaffolding. And then the process of pouring concrete, again, just to highlight, in Hong Kong is a specific concern. The method of pouring concrete here has tolerances of 25 to 35 mil, as opposed to the, say, 5 to 10 mil that we would expect internationally. So for spaces like this, which rely on that concrete for acoustic value, it's really a particular concern that you have to monitor. And relevant to those extensive studies of sightline and audience relationship to stage, a 25 millimeter deviation row to row in a theater, it makes a different theater. It's no longer the same room. So that kind of tolerance was not acceptable here. And we had to actually monitor the pouring process in these rooms specifically. And then the final outlook, as it will be unveiled this year. And then to pull back, just a repeat of the main performance venue of the Grand Theater. It's gardens and lobbies elevated in the air. The outdoor public theater and the tea house off of the Grand Stair are a series of performance venues which are housed in the CUHK Center, as well as the education wing, which wraps around the upper level to provide an experimental home for CUHK and the years to come.
You can see how the aluminum curtain wall changes depending on the light. So you have gold on one side, which is the sunset, and then at night it's lit from the top and to the whole facade closed.
So that is the conclusion of our presentation about this issue. And then we also just wanted to remark that another of our projects in Hong Kong is completing this year at the Chicago Food School of Business, and that we look forward to inviting you all to visit it when it opens its doors. We'll be happy to give it a tour.